Imagine writing a perfectly elegant mathematical equation. It's flawless, structurally sound.
Right.
But the absolute second you attempt to show that equation to someone else or save it to your hard drive or even print it on a piece of paper, it becomes quote-unquote contaminated.
Contaminated, yeah.
It is no longer pure. And I mean, that is the actual terminology used by some of the most advanced programmers in the world.
It sounds extreme, I know. But treating the real world as a source of contamination is essentially, well, it's the foundational philosophy of functional programming.
Wow.
Yeah, it forces a developer to draw this really hard line between perfect theoretical logic and, messy reality.
And we are jumping straight into that divide today. Welcome to the deep dive, everyone.
Glad to be here.
Today, we are unpacking a personal journal entry from a developer named Ang. It's titled Notes on Haskell Programming, Part 119, published on April 25, 2026.
Which is quite the milestone.
Yeah, I mean, before we go any further, the fact that this is Part 119 tells us we are dropping into the middle of a serious, sustained intellectual marathon here.
Absolutely. Ang is teaching themselves Haskell, which, if you're not familiar, is this notoriously difficult math-based programming language.
Right, and the mission for our deep dive today is to explore the intersection of that highly technical software engineering and really the very human process of learning a complex skill.
Exactly, because Ang's journal isn't just some dry instruction manual. It's really a real-time log of a human brain rewiring itself to think differently.
And I want to say right up front to you, listen, even if you have never written a single line of code in your life, stick around. The way Ang approaches problem solving here, it translates to almost any discipline.
Oh, 100%.
We're going to look at how a complex application is actually constructed from the ground up, explore that deep philosophical difference between pure and impure actions that we just mentioned, and tackle a fascinating question about learning.
Right, the AI question.
Yes. In an era of instant artificial intelligence, why is taking the slow, difficult route sometimes the only valid option?
It's a great question. And to kind of ground this in what Ang is actually building today, they are working on a specific tool within a much larger application.
Okay, lay it out for us.
So the goal of this tool is to take parsed content, what developers call tokens, and convert them into different ebook formats.
Okay, let's define what a token is for a second, just so we're all on the same page.
Sure.
If you take a sentence in a book, the computer doesn't just read it like a human does. It chops that sentence up into a list of categorized pieces, right? The tokens.
Exactly. It labels one chunk, bold text and another chunk italic text.
Or like a paragraph break.
Right. And Ang's application is taking these raw, chopped up tokens and trying to stitch them back together into a polished file.
Like an EPUB or a PDF.
Exactly, using a really popular universal document converter called Pandoc.
Pandoc. Okay.
Yeah.
But Ang doesn't start by writing the complex Pandoc conversion logic right out of the gate, do they?
No, not at all. They start by setting up the plumbing.
The plumbing. I like that.
Yeah, they're focused on clean data management and creating what developers call a stub function.
Right. And the stub function Ang creates here is simply named convert to ebook.
Simple enough.
Yeah. But before filling in the actual details of what this code will do, Ang makes some very deliberate architectural choices about how information is going to flow into this function.
Which is crucial in Haskell.
Yeah, the journal notes a specific refactoring. Basically, instead of passing a bunch of individual loose arguments to this function, Ang decides to package everything into a single record called valid args.
And honestly, how you hand data from one part of the program to another dictates the entire lifespan and maintainability of that software.
Really? Just how you hand it over?
Oh, yeah. I mean, think about it. If a function requires a file name, an export format, a list of tokens, and a user configuration.
That's a lot of stuff.
It is. And passing them one by one creates a massive headache.
I was picturing this like preparing someone for a business trip.
Okay, yeah.
Passing individual arguments is like tossing someone 15 loose sheets of paper, a calculator, a pen, and a plane ticket while they're literally running out the door.
Right, they're fumbling with it all.
Exactly. It's chaotic. The person is likely to drop something. And if you later decide, oh, wait, they also need a passport, you have to sprint after them and throw that into the pile, too.
That's a great way to visualize it.
But packaging all of this into valid args, that's like handing them a fully packed, perfectly organized briefcase.
And Ang notes exactly why this matters in the code. It prevents the function signatures from growing into these long, unreadable strings of text.
Right, the dreaded alphabet soup.
Exactly. If you want to add a new requirement later, you just put it inside the briefcase. You don't have to change how the briefcase itself is handed over.
That makes so much sense.
Yeah.
And they're applying this clean organization everywhere in the project.
Yeah, they really are.
For instance, Ang uses a common export format data type. And if you've been following along with their journal, this was actually refactored back in part 118.
Right. They move the definition of an export format into a completely separate shared module.
Which means the entire application has one single source of truth for what an ebook format is, rather than redefining it in 50 different places.
Which saves you from so many bugs down the line. Ang also updates something called a cabal file.
Ah, the cabal file.
Yeah.
Specifically, xs2ebook.cabal.
Right. And this is generated by a build tool named Stack. In the Haskell ecosystem, you can think of the cabal file as basically the master blueprint for the house.
The blueprint, Nika.
Yeah, it tells the system exactly which rooms or modules exist and which ones are allowed to talk to the outside world.
So Ang updates this blueprint to expose the xs2ebook.cli module, right? Which handles the command line interface where the user actually types commands.
Yep, and they add the new xs2ebook.converter module, which is kind of the engine room.
The engine room. So by updating that blueprint, Ang is essentially unlocking the door so the human user can eventually talk to the conversion engine.
Precisely. The system knows the modules exist. The data is packed in that clean briefcase record, but there still needs to be a physical place for this action to happen.
You have to designate a plot of land before you pour the concrete.
Right. And in software architecture, that plot of land is the stub function.
So a stub is really just an architectural placeholder.
Basically. You define the inputs that will go in, you define the outputs that will eventually come out, and you put a simple sticky note in the middle that says, insert complex logic here later.
Just a sticky note. That's funny. But it makes sense. It allows the developer to test the flow of the entire application without getting bogged down in the minutiae of the pan conversion right away.
Exactly. But defining those inputs and outputs in Haskell requires writing a type signature.
And this is where Ang makes a really, honestly, and incredibly relatable admission.
Oh yeah, I love this part.
Ang notes that while they can read these intimidating type signatures at a glance, they still struggle to write them from scratch manually.
Which is so common. The compiler in Haskell demands absolute mathematical precision it does not forgive.
And the target type signature Ang is trying to write for this stub, it literally looks like a string of algebra.
It really does.
It reads, convert to ebook, then double colon, export format, an arrow, file path, an arrow, token in brackets, an arrow, IO, either string.
I know, hearing code read out loud can sound like a completely foreign language.
It's a lot. But breaking down what these symbols represent opens up this massive discussion on how programming languages view the real world.
Let's do it.
Let's start with the first three pieces. Export format, arrow, file path, arrow, token. These are the inputs, right?
Right. The function needs to know the format, like eteb. It needs the file path, which is where it should be saved. And it needs the list of tokens, which is the actual content.
And those arrow symbols just indicate the flow of data. Those three inputs flow into the second half of the signature, which begins with the letters I-O.
Yes, I-O. And this is the crucial distinction we hinted at earlier, that divide between pure and impure functions.
Okay, let's get into this, because this fascinated me. A pure function exists in a completely sterile, predictable vacuum.
Like a mathematical formula.
Right. If you give a pure function the number 2 and ask it to multiply by 2, it will return 4.
Always.
Always. It returns 4 today, it returns 4 tomorrow, and it will return 4 a million years from now.
Yeah.
It has absolutely zero side effects.
But convert to ebook is not pure.
No.
It is marked with I/O, which stands for input-output. And the moment your code needs to read a template file from a hard drive, or write a new file to the disk, or print results to a console, it touches the outside world.
That's contaminated.
It's contaminated because the outside world is totally unpredictable.
Right.
A hard drive might be full, a file might be corrupted, the user might literally unplug the computer from the wall. Because of this unpredictability, the function becomes impure.
Okay, so I'm looking at this pure versus impure divide, and I'm honestly a bit hung up.
How so?
Well, if pure functions are structurally flawless, they always give the same predictable output, they never have side effects, my immediate thought is, why write an impure function at all?
Right.
Like if I'm building an app, I want to ban all impure functions and write an entire program out of perfectly pure, crash-proof code.
That sounds ideal.
But as I say that out loud, I realize a perfectly pure program couldn't even display a welcome message on my screen, right? Because printing to a monitor interacts with the physical world.
Exactly.
So the 100% pure program is essentially useless, isn't it?
It is entirely useless in isolation. A program made strictly of pure functions just sits inside the processor thinking perfectly logical thoughts, but it can never show you those thoughts.
Wow.
It can never save your work, and it can never send an email. To have any real utility for a human being, software must interact with the messiness of the real world.
You have to get your hands dirty.
You do, you have to. But the way Haskell handles this is unique.
How so?
Well, in a lot of mainstream programming languages, you can bury a command to write to the hard drive deep inside some obscure math function, and the rest of the program has no idea it's happening.
Like a secret side effect.
Exactly. The side effect is hidden. But Haskell refuses to allow that.
Right.
If a function touches the outside world, you must prominently label its signature with IO. It is a strict quarantine system.
A quarantine. I love that.
Yeah, it forces developers to isolate the messy, unpredictable parts of the code from the perfectly clean mathematical parts.
Which completely changes how you approach testing the software, right?
Oh, entirely.
Eng points out that if you find yourself needing mocks for a test, you're dealing with an impure function.
Right. And for anyone unfamiliar with the term, a mock is basically a fake version of a real-world object.
Like a stunt double.
Yeah. If you want to test code that saves a file, but you don't actually want to fill up your real hard drive during the test, you build a fake temporary hard drive, a mock.
And Eng is noting that pure functions never need mocks because they don't interact with the environment at all.
Exactly. Only the impure IO-contaminated functions require these elaborate testing setups.
Okay, so since IO means the function is interacting with the messy, unpredictable real world, the program also needs a strict plan for handling the inevitable successes and failures of those interactions, right?
It absolutely does. And that brings us to the final part of Eng's intimidating signature. Either string.
Either type. It's exactly what it sounds like. It mandates that the function will return one of two possible outcomes.
Right. And according to Eng's notes, those two outcomes are left string or right.
Let's break those down. Left is conventionally used in Haskell to represent an error, right?
Yes. So in this case, left string means if the real-world interaction fails, the function will return a text string, a literal string of words explaining what went wrong.
Like hard drive full or file not found.
Exactly.
Okay. And the right side represents success. But the syntax here is just an open and closed parenthesis.
Yeah, Eng explains that this is known as unit.
Units.
Right. It basically means the function succeeded, but it has no actual data to hand back to you. The job is just done.
When you synthesize all of that, Eng provides this brilliantly simple summary for themselves. They say IO, either string, simply means this function does something with side effects, which can either fail with an error message or succeed without returning any data.
It really demystifies the algebra, doesn't it?
It does. And honestly, I found myself translating this into a delivery driver analogy just to visualize how strict this actually is.
Oh, let's hear it.
Okay, think of the delivery driver as the function. The driver has to navigate the messy real-world traffic, locked gates, bad weather. That is the IO.
The contamination.
Right. The outcome of their delivery attempt is the either. They have exactly two options. Option one, they leave a sorry we missed you note on your door, which is a literal string of text explaining why the delivery failed.
That's the left string.
Exactly. Option two, they successfully drop the package on your porch, turn around, and walk away without saying a single word to you.
I like this driver.
Right. They don't hand you a receipt. They don't ask for a signature. They just silently succeed.
And that silent success is the unit.
Exactly.
It perfectly captures the binary nature of navigating a complex environment because think about how often the apps on your phone crash or suddenly freeze.
All the time.
Right. And it is almost always because the code behind that app encountered an unpredictable real-world event, like a dropped network connection or a missing image. And the developer didn't strictly define what should happen next.
The app just panics and shuts down.
Exactly. What Haskell is doing with our either string is forcing accountability.
You cannot even compile the program until you prove to the system that you have a plan for the sorry we missed you note.
That's the beauty of it. It forces you to handle reality.
Now, right now, inside Eng's current stub, the code is just pretending to do the delivery. It isn't converting any tokens yet.
Right. It's just the sticky note phase.
Yeah, the stub simply executes the command, put strln converter stub, which prints those words to the console so Eng knows the plumbing is actually connected.
Right.
Then it bypasses any potential errors and returns a pure success.
Right.
Pure door.
Right.
The driver drops an empty box, gives a thumbs up, and just vanishes.
It proves the wiring works before you turn on the high voltage, which is smart.
Very smart.
Yeah.
But defining these strict rules and constantly thinking in terms of I/O and either, it requires a massive mental shift.
It really does. You have to totally rewire how you approach problem solving.
And this friction in learning leads directly to Eng's personal reflections at the end of the journal entry.
This was my favorite part of the notes.
Yeah, Eng talks about why learning this specific paradigm sharpens the mind. And notably, they address why letting artificial intelligence do the work for you defeats the purpose entirely.
Right. And keep in mind, this journal is written in April 2026.
Hmm.
AI tools for coding are deeply, deeply integrated into the developer ecosystem at this point.
Oh yeah. Eng acknowledges that it would be incredibly easy to just prompt an AI to build this complex pandoc conversion logic instantly.
But Ang strongly resists that.
Yes, they do. They note that the code produced by AI in these complex languages is often of highly questionable quality.
To put it mildly.
Right. It is either factually incorrect or it is absurdly overly engineered. Eng specifically calls out that for a strict language like Haskell, AI has a nagging tendency to generate what they call pro-Haskell code of alphabet soup.
Alphabet soup. Yeah, and alphabet soup basically refers to code that might technically execute, but is so dense, so layered in obscure syntax that it completely destroys human readability.
It's just a wall of symbols.
Exactly. And if the goal of functional programming is clear, maintainable architecture, well, generating unreadable alphabet soup fundamentally breaks that architecture.
But beyond just the quality of the code, Eng realizes that leaning on AI directly impacts their actual cognitive progress.
This is the crux of it.
They state that for hobbyist projects, where the primary focus is on learning and expanding the mind, they strictly prefer using AI merely as a glorified search engine, or, my favorite, a rubber duck programming partner.
Ah, the rubber duck. It is a classic engineering technique.
Explain the rubber duck for us.
Okay, so when a developer is stuck on a problem, they will literally place a little rubber duck on their desk and explain their code line by line out loud to the inanimate object.
Which sounds crazy if you walk by their desk.
It looks ridiculous, but the simple act of forcing your brain to articulate the logic out loud often makes the flaw suddenly obvious.
You're your own mistake.
Exactly. And Aang is using the AI as the duck.
Right. They aren't asking the AI to drive the car. They are bouncing ideas off it while retaining the heavy cognitive load of actually writing the logic themselves.
They're maintaining the struggle.
Maintaining the struggle. This highlights a really crucial distinction between shipping a product and learning a craft.
Right. If your only metric is getting a widget out the door by Friday, perhaps you just let the AI write the alphabet soup and you just hope it holds together.
Right. Who cares as long as it ships?
But if your goal is to truly understand the mathematical beauty of pure and impure functions, well, the alphabet soup robs you of the necessary struggle.
It does.
When you fight to write that I/O, either string signature from scratch, you are physically building neural pathways.
You completely bypass the aha moment if the machine just solves the puzzle for you.
Exactly.
Which brings us to Eng's final advice to themselves in the journal. Take it slowly and enjoy the process.
In a culture totally obsessed with optimization and speed, choosing the slow, deliberate path is, honestly, a radical approach to achieving deep comprehension.
It really is. Wrapping up this dive into Eng's notes, the core takeaways extend far beyond Haskell.
Oh, absolutely.
Whether you are building
You have to build clean scaffolding.
Right. Setting up those stubs and organizing your inputs into that briefcase so you aren't carrying loose papers.
Yeah.
You have to understand the difference between the perfect, pure theory you study in a textbook and the messy, unpredictable reality of the impure world where things fail and errors must be accounted for.
The delivery driver has to leave a note.
Exactly. And above all, you have to embrace the slow, deliberate friction of learning.
You know, it makes you wonder if Aang is right, and the struggle of grappling with that complex alphabet soup is exactly what builds our mathematical logic and our neural pathways. What happens when AI fully succeeds in removing all friction from our daily problem solving? If we outsource the struggle, do our cognitive abilities eventually atrophy like an unused muscle? Is the friction itself actually the most valuable product we produce?
Wow. That's a lot to chew on.
Something to keep pondering.
Definitely. Keep pondering that, everyone. Thanks for joining us on this deep dive. We'll see you next time.